Today's edition of SpaceTime is brought to you by our new sponsor, Brilliant.org. Maths and science done right. Learn to think like a scientist with their carefully curated lists of puzzles and questions. Check them out today and use the link brilliant.org/Stuart Gary so they know you've come from us. Once again, that's brilliant.org/Stuart Gary. This is SpaceTime Series 20, Episode 74. Coming up on SpaceTime. Could interstellar ice provide the answer to the birth of DNA? The mysterious night side of Venus? And a Charmonian surprise at the Large Hadron Collider. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study claims molecules brought to Earth in meteorite strikes could potentially have been converted into the building blocks of DNA. A report in the journal Chemical Communications claims researchers have found organic compounds known as amino nitriles, the molecular precursors of amino acids, were able to use molecules present in interstellar ice to trigger the formation of 2-deoxy-D-ribose, the backbone molecule of deoxyribonucleic acid, or DNA. The origin of important biological molecules has been one of the key fundamental questions of science. It's long been assumed that amino acids were present on Earth long before DNA and may even have been responsible for one of its core building blocks. But this new research is throwing doubt on this theory. One of the study's authors, Dr. Paul Clark from the University of York, says the molecules that form the building blocks of DNA had to come from somewhere. So, either they were present on Earth when it formed 4.6 billion years ago, or they came later from space, arriving at Earth in meteor showers. Scientists have already shown that there were particular molecules present in space that came to Earth in an icy comet. And so Clark and colleagues looked to see whether these molecules could have been used to make the building blocks of DNA. If this was possible, it would mean the building blocks of DNA were already present before amino acids. In order for cellular life to emerge and then evolve on Earth, the fundamental building blocks of life first needed to be synthesized from appropriate starting materials, a process sometimes described as chemical evolution. The research team showed that amino nitriles could have been the catalyst for bringing together interstellar molecules, formaldehyde, acetaldehyde, and glycoaldehyde, before life on Earth began. Combined, these molecules produce carbohydrates, including 2-deoxy-D-ribose, the building blocks of DNA. DNA is one of the most important molecules in living systems, yet the origin of 2-deoxy-D-ribose before life began on Earth has remained a mystery. Clark says the new research demonstrates that the interstellar building blocks formaldehyde, acetaldehyde and glycoaldehyde can be converted in one pot to biologically relevant carbohydrates, the ingredients of life. So this research therefore outlines a plausible mechanism by which molecules present in the interstellar medium brought to Earth in meteorite strikes could potentially be converted into 2-deoxy-D-ribose, a molecule vital for all living systems. You're listening to SpaceTime. I'm Stuart Gary. The winds and upper cloud patterns on the night side of the planet Venus have been characterised for the first time, in the process giving scientists some surprising results. A report in the journal Nature Astronomy claims the atmosphere on Venus's night side behaves very differently from that on the day side of the planet, the side facing the Sun. As a result, nocturnal Venus exhibits some unexpected and previously unseen cloud types, morphologies and dynamics, some of which appear to be connected to features on the planet's surface. The study's lead author, Javier Peralta from the Japan Aerospace Exploration Agency JAXA, says it's the first time scientists have been able to characterise how the atmosphere circulates on the night side of Venus on a global scale. While the atmospheric circulation on the planet's day side has been well explored, there remains much to discover about nocturnal Venus. Venus is often described as Earth's sister planet. Both are similar in size, mass, bulk composition, and were formed under the same conditions in the same part of the solar system. But if Venus is Earth's sister planet, then it's a twisted sister, with a super thick carbon dioxide atmosphere, 100 times the pressure at sea level on Earth. Its runaway greenhouse effect means the surface temperatures on Venus reach over 460 degrees Celsius, hot enough to melt lead, and hotter than the surface temperature on any other planet in the solar system, including Mercury, the planet nearest the Sun. Even stranger, a day on Venus lasts 243 Earth days. Because Venus is a bit closer to the Sun than the Earth, a Venusian year lasts just under 228 Earth days. So what that means is a day on Venus is actually longer than a year on Venus. And Venus is the only planet in the solar system to have retrograde rotation. In other words, it rotates backwards with the Sun rising in the west and setting in the east. Venus is shrouded by an opaque layer of highly reflective clouds of sulfuric acid, preventing its surface from being seen from space in visible light. Also, because the clouds are sulfuric acid, when it rains on Venus, it rains sulfuric acid, and metallic snow falls on the mountaintops. In earlier days, scientists speculated that all those clouds over Venus meant there must have been a lot of rain going on there. And all that rain must have meant thick tropical rainforests. And when you have ancient rainforests, you must have dinosaurs. After all, we've all seen Jurassic Park. Of course, we now know nothing could be further from the truth. Venus's surface is a dry, barren desertscape, interspersed with slab-like rocks and periodically resurfaced with volcanism. Venus's atmosphere is dominated by strong winds, which whirl around the planet far faster than Venus itself rotates. This phenomenon, known as superrotation, sees Venusian clouds rotating at up to 60 times faster than the planet below, pushing and dragging along clouds within the atmosphere as they go. These clouds are travelling fastest at the upper cloud levels, some 65 to 72 kilometres above the surface. Scientists have spent decades studying these superrotating winds by tracking how the upper clouds move on Venus's day side, which are clearly visible in ultraviolet images. However, models of Venus have been unable to reproduce this superrotation. And that means that there must be something missing from the puzzle. Peralta and colleagues focused on the night side because it's been poorly explored. They could see the clouds on the planet's night side by their thermal emissions. But it's been too difficult to observe them properly because the contrast in previous infrared images was too low to pick up enough detail. So Peralta and colleagues turned to the visible and infrared thermal imaging spectrometer aboard the European Space Agency's Venus Express spacecraft in order to observe the clouds in infrared at better resolution. The Venus Express observations allowed the authors to see these clouds properly for the first time, letting them explore what previous teams could not. Rather than capturing single images, Venus Express gathered a cube of hundreds of images of Venus, acquired simultaneously at different wavelengths. This allowed the team to combine numerous images to improve the visibility of the clouds. This allowed them to see the clouds in unprecedented resolution, revealing phenomena on Venus's night side that had never been seen on the day side. The best models for how Venus's atmosphere behaves and circulates, known as global circulation models, predict superrotation to occur in much the same way on Venus's night side as it does on the day side. However, the new research by Peralta and colleagues is contradicting these models. Instead, the superrotation seems to be far more irregular and chaotic on the night side. Night-side upper clouds form different shapes and morphologies from those found elsewhere, large, wavy, patchy, irregular and filament-like patterns, many of which are unseen in day-side images and are dominated by unmoving phenomena known as stationary waves. Scientists think stationary waves on Venus are probably the same as gravity waves on Earth, rising waves generated lower in Venus's atmosphere that appear not to move with the planet's rotation. These waves are concentrated over steep mountainous regions of Venus, suggesting the planet's topography is affecting what's happening way up above in the clouds. The three-dimensional properties of these stationary waves were also obtained by combining the spectroscopic data from Venus Express with radio science data from another instrument aboard the spacecraft, the Venus Radio Science Experiment. The link between atmospheric motion and topography has been spied on Venus before, however that was on the planet's day side. In a study published last year, researchers found weather patterns and rising waves on the day side of Venus to be directly connected to topographic features on the surface. The new findings also support observations by a separate study which has also independently discovered stationary clouds on the planet's night side, this one using NASA's Infrared Telescope facility in Hawaii. The new findings were then confirmed when JAXA's Akatsuki spacecraft achieved Venus orbit insertion and immediately spotted the biggest stationary wave ever detected in the solar system on Venus's day side. This finding raises challenges for existing models of stationary waves. Such waves were thought to be formed by surface winds interacting with obstacles such as mountains. The problem is previous Soviet Union and Russian missions involving landers have measured surface winds on Venus that were far too weak for this to be true. Additionally, the planet's southern hemisphere, where Venus Express was observing, is generally quite low in elevation, And, more mysteriously, stationary waves appear to be missing in Venus's intermediate and lower cloud levels, roughly up to about 50 kilometres above the surface. Scientists expected to find these waves at lower levels because they're seen at upper levels, and researchers thought that they rose up through the cloud from the surface. The new unexpected observations will mean a revision of science's current models of Venus, in order to try and understand what's really happening. The effect of topography on atmospheric circulation remains unclear among climate modelers. Many models show that the inclusion or omission of surface topography really does make a difference in the resulting behaviour seen in Venus's atmosphere. But they do not show any persistent weather patterns linked to that topography. So what does this all mean? Well, clearly the study challenges current understanding of climate modelling, and more specifically the superrotation, which is a key phenomenon seen on Venus. This is SpaceTime. I'm Stuart Gary. Okay, let's take a break from the show and talk about our new sponsor, Brilliant.org. There are lots of people to thank for supporting SpaceTime, and one group that deserves special thanks right now is Brilliant.org. In fact, if you're at your computer right now, go check out their site, brilliant.org/Stuart Gary, and see what they're all about. Videos and books give you ideas and explanations, but the thing is, science and maths aren't just spectator sports. The only way to actually solidify learning is with your own exploration and problem solving. For example, when I was at uni, I wasn't just told about equations like Newton's law of universal gravitation or Einstein's mass-energy equivalence. I had to repeatedly apply these laws to solve real problems. And you know what? It felt good. And that's why I think anyone listening to SpaceTime would love Brilliant.org, because they're a problem-solving website that teaches you to think like a scientist. Brilliant.org offers really well-curated sequences of guided questions. And having played around on the site, I can tell you a lot of thoughtful hard work's gone into making these as good as they are. And the subscription they're offering to get a full suite of problems is a really good deal. Plus, there's a whole host of free material to try out. Go and have a play with their astronomy toolbox. I think you'll find it fun. And of course, if you love listening to SpaceTime, you can support the show by going to brilliant.org/Stuart Gary, or follow the links in our show notes or on our website. That lets them know you came from here. That's brilliant.org/Stuart Gary. Give it a try. And now, back to the show. Astronomers have detected titanium oxide in the atmosphere of an exoplanet for the first time. The findings, reported in the journal Nature, show that the atmosphere of the exoplanet WASP-19b contains small amounts of titanium oxide, as well as water vapour and traces of sodium, alongside a strongly scattering global haze. WASP-19b orbits the distant star WASP-19, located some 815 light-years away in the southern constellation of Vela, the ship's sails. The planet is a hot Jupiter, with one of the tightest orbits known around any star. In fact, a year on this planet takes just 19 hours. The exoplanet is slightly more massive and about a third larger in diameter than Jupiter, the largest planet in our solar system. Orbiting so close to its host star, it's no wonder that WASP-19b has a surface temperature of over 2,000 degrees Celsius. That's as hot as some low-mass stars. But although a gas giant, the planet isn't massive enough to be a brown dwarf, or undergo core nuclear fusion, the process which makes stars shine. Astronomers examined WASP-19b's atmosphere using the European Southern Observatory's Very Large Telescope, the VLT, located in Chile's high Atacama Desert. It provided researchers with unique information about the chemical composition and the temperature and pressure structure of the atmosphere of this unusual and very hot world. As WASP-19b passes in front of the host star as seen from Earth, some of the starlight passes through the planet's atmosphere and leaves subtle chemical fingerprints in the light which eventually reach Earth and can be examined spectroscopically. However, detecting the exoplanet's atmospheric molecules required the authors to use special algorithms that explores many millions of spectra spanning a wide range of chemical compositions, temperatures and cloud or haze properties. Titanium oxide is rarely seen on Earth. It's known to exist in the atmospheres of cool stars. In the atmospheres of hot planets like WASP-19b, it acts as a heat absorber. If present in large enough quantities, these molecules prevent heat from entering or escaping through the atmosphere. That leads to a thermal inversion, with temperatures being higher in the upper atmosphere and cooler further down, which is the opposite of the normal situation. Ozone plays a similar role in Earth's atmosphere, causing an inversion layer in the stratosphere. The presence of titanium oxide in the atmosphere of WASP-19b would have significant effects on the planet's atmospheric temperature, structure and circulation. To examine an exoplanet with this level of detail required more than a year of observations. By measuring the relative variations in the planet's radius at different wavelengths of light that pass through the exoplanet's atmosphere, and then comparing those observations to atmospheric models, the authors were able to extrapolate different properties such as the chemical content of the exoplanet's atmosphere. This new information about the presence of metal oxides like titanium and other substances will allow better modelling of exoplanetary atmospheres in the future. And once astronomers are able to observe atmospheres of possibly habitable planets, the improved models will give them a much better idea of how to interpret those observations. To find out more, Andrew Dunkley is speaking with Dr. Fred Watson from the Australian Astronomical Observatory.
This exoplanet that has been discovered with this unusual atmospheric trait, what's this all about?
Yeah, so it's a great story. So the headline in the news release, which comes from the European Southern Observatory, is "Inferno World with Titanium Skies." Doesn't that paint a picture?
It sounds interesting.
Yeah. So what's happened is, and this is really, really clever astronomy, there is an exoplanet. So this is a planet going around another star. It's got the wonderful name of WASP-19b. It was discovered by a project called WASP. You know, they look for exoplanets. They look for the signature of a planet passing in front of its parent star. What happens is the parent star's light dims as the planet goes in front of it. So that was discovered quite some time ago. We know this planet is what's called a hot Jupiter. That means it's of the order of the size of Jupiter, extremely hot because it's so close to its parent star that it orbits in, guess what? Not a year, 19 hours.
Wow.
So 19 hours is 1 year for this planet. The estimate is that its atmospheric temperature is about 2,000 degrees Celsius. Now, that clearly is too hot for life as we know it, probably too hot for life of any kind. But it is a temperature that's kind of at the lower end of the scale of temperatures for stars. So this is not a star, it's definitely a planet, but has some characteristics of a star.
It's a
Stanet.
That's about as far as it gets.
Yes, or it could be a stanet, yeah. I don't know. We need to invent a name for those. Planetar or something like that. Anyway, it's a big planet, not quite a small star. But what that means...
I've got a name. A staroid.
Oh, I like that.
You like
that? It sounds like something you buy in a chemist shop.
It does, doesn't it?
Can I have a box of steroids, please? No, we won't go there. Anyway, the thing about this planet is that it may be expected that its atmosphere has some similar sort of chemistry to certain stars. And what has now happened is that the scientists at the European Southern Observatory, which you'll remember operates the 4 giant dishes of the Very Large Telescope down at Paranal in Chile, they have used one of their instruments to very, very cleverly analyze what chemicals are present in the atmosphere of this planet. And the way they do that is that as the planet passes in front of the star, some of the light's blocked out, and that's why the star's light dims. But some of the light actually passes through the atmosphere of the planet. And you can imagine this thing classic, passes the disk of the planet, passes in front of the star. There's a little band around it, a kind of annulus, in which the light can pass through the atmosphere. I'm making all the gestures here, which I know you can see, but nobody else.
I'm relaying them telepathically.
Thank you. Telepathically, that's good. And so when you do that, it means that if you apply a spectrograph to the light of the star, which is really all you can see, at the time when the planet passes in front of it, and a spectrograph, of course, breaks the light into its rainbow spectrum of colours and reveals this barcode of information that tells you what's in there. When the planet passes in front of the star, that spectrum is going to change. You will get features in it, in the barcode, which belong to the planet's atmosphere rather than the star itself. Are you with me so far?
I am, sort of. Yes.
Yes. So the light going through the planet's atmosphere picks up a signature of what's going on in the planet's atmosphere. And we can decode that with the spectrograph. And what they have found is what we call bands, actually. Bands are a particular type of barcode. It's nothing to do with music. It's just, lots and lots of different very fine spectrum lines. That's the technical term. And those bands are due to titanium oxide. It's cool enough for these molecules to form. If it was much hotter than that, they would dissociate into titanium and oxygen. But titanium oxide is interesting because it's found commonly in the atmosphere atmospheres of cool stars. In a way, that the highlight of this story is that they've done it at all. It's an extraordinary achievement, but it is the first time we have found titanium oxide in an exoplanet atmosphere. It's a kind of a step forward. It doesn't mean that if you stood on the surface of the planet, heaven forbid, because at 2000 degrees Celsius, you wouldn't last long. It doesn't mean that you could look up and see these steely grey skies of titanium. It just means that we know that this compound, titanium oxide, is present in the atmosphere.
On the plus side, though, your hamburger and chips would be hot.
They'd certainly be hot, and they'd probably be shiny as well with the titanium. Yeah, so a great story and a great achievement from the scientists at ESO.
Yeah, quite amazing. And what I find fascinating is that the more we discover, the more things seem to be different or beyond what we think is normal. We're starting to find all these unusual traits about exoplanets and other stars and black holes and you name it. The better we get at searching and finding, the more variation we find, I suppose.
That's right. The more extraordinary things we discover, that's the bottom line. It is amazing. There is an implication of this titanium oxide. If there's enough of it, apparently it acts as a heat absorber, and so it may stop heat leaving the atmosphere. And the suggestion is that might give you what we call a thermal inversion, which we see commonly on Earth. The thermal inversion means the temperature is higher the higher you go in the atmosphere rather than the other way around. You know, normally the temperature, as we all know when we climb on board a jet and see the temperature outside dropping to minus 50 or something, that's because we're a long way from the surface of the Earth. If you're a long way from the surface of this planet, it might be getting even hotter if there is a temperature inversion due to the titanium oxide.
Quite incredible. All right. Who knows what else we're going to find out there, Fred, but I'm sure we'll find something soon.
And I'm sure that you and I will be talking about it when we do.
That's Dr. Fred Watson from the Australian Astronomical Observatory speaking with Andrew Dunkley on our sister program, Space Nuts. And this is Space Time. I'm Stuart Gary. The L8CB experiment at the world's largest atom smasher, the Large Hadron Collider, has surprised physicists by providing unprecedented precision measurements of the masses of two charmonium particles, something never previously achieved at a Hadron Collider and until recently thought impossible. Until now, precise research into charmonium particles has required the construction of dedicated experiments in order to examine this invaluable source of insights into the subatomic world. The two particles, XE1 and XE2, are excited states of a better-known particle called J-sign. An excited state is a particle that has a higher internal energy, namely a mass, than the absolute minimum configuration which is allowed. Mesons are hadron particles, formed by a charm quark and its antimatter counterpart, the charm antiquark, and bound together by the strong nuclear force. The J-sign and its excited states are referred to as charmonium. Quarks are elemental subatomic particles which come in 6 types or flavours, known as up, down, top, bottom, charm and strange. These particles differ from each other only in their masses, and they have either plus 2/3 or minus 1/3 charge. Just like ordinary particles, a meson can be observed in excited states where the two quarks move around each other in different configurations. And because of Einstein's famous equivalence of energy and mass equation, E equals mc squared, after a tiny amount of time, these particles can disappear and transform into some other particles of lower masses. The L8CB experiment studied the particular transformation of XE1 and XE2 mesons decaying into a J-sign particle and a pair of muons in order to determine some of their properties very precisely for the first time. Muons are elementary lepton particles similar to electrons with a charge of -1 and a spin of 12, but with far greater mass. Previous studies of XE1 and XE2 at particle colliders have exploited another type of decay of these particles featuring a photon in the final state instead of a pair of muons. The problem is, trying to measure the energy of a photon is experimentally very challenging, especially in the harsh environment of a Hadron Collider. And that's where the specialised capabilities of the L8CB detector come in. It's capable of measuring trajectories and properties of charged particles like muons. This allowed scientists to exploit the large data set accumulated during the first and second runs of the Large Hadron Collider up to the end of 2016, letting them observe the two excited particles with excellent mass resolution. Exploiting the novel decay of two muons in the final state, the new measurements of XC1 and XC2 masses and natural widths have a similar precision and are in good agreement with observations obtained in earlier dedicated experiments built with a specific experimental approach very different from that in use at colliders. As well as no longer being obliged to resort to purpose-built experiments for such studies, the breakthrough will also allow physicists to think about applying a similar approach for the study of similar classes of particles known as potomonyms, where the chum quarks are replaced with bottom quarks. These new measurements, along with future updates and larger data sets of collisions accumulated at the Large Hadron Collider, will allow new stringent tests for the predictions of quantum chromodynamics. Quantum chromodynamics describe the behaviour of the strong nuclear force. The Large Hadron Collider is a 27-kilometre circular particle accelerator built under the Franco-Swiss border by CERN, the European Organisation for Nuclear Research. Packets of photons or other atomic nuclei are fired around the ring at speeds approaching 99.999% the speed of light. The packets are guided by powerful cryogenically cooled electromagnets to smash into each other at one of 4 detectors positioned around the collider. Scientists then trawl through the collision debris created by these extreme events to discover new particles and forces, in the process helping to unlock some of the fundamental principles of the universe. I'm Stuart Gary. You're listening to SpaceTime. A SpaceX Dragon cargo ship has splashed down in the eastern Pacific Ocean southwest of Long Beach, California. The Dragon CRS-12 capsule was carrying just under 2 tons of equipment and completed science experiments from the International Space Station. The capsule had undocked from the space station's Earth-facing Harmony module 5.5 hours earlier as the pair flew some 400 kilometres above Australia.
And just like that, Dragon has been released, getting the call. The snares are open, 3:40 right on time. Again, we'll slowly start to see Dragon separate a bit from the robotic arm there. It's going to get slowly drawn back, and then Dragon will be able to execute all of those departure burns. The robotic arm slowly retracts away from Dragon. Again, that release coming right on time, 3:40 a.m. Central, 4:40 a.m. Eastern, while the station flew to the south of Australia. The arm continuing to slowly back away. The first of several departure burns coming up any moment now. The arm already about 1 meter away. 2 meters in opening. The capsule coming fully into view there. And so with the arm backed away, the departure burns being armed. And the first departure burn has begun.
Excellent, good job, and thank you.
Visiting vehicle officer here in Houston reporting everything looking good.
Station Houston on 2, departure burn 1 is complete. Departure burn 2 in approximately 1 minute.
Station copies.
So in about 30 seconds, the second departure burn should begin, and Dragon slowly making its way out of the neighborhood of the International Space Station. Again, it's going to execute a series of these departure burns, slowly getting further and further away. It's going to exit what's known as the keep-out sphere and the approach ellipsoid, and those are basically imaginary boundaries drawn around the International Space Station, where a lot of rules and coordination with the International Space Station Flight Control Team come into play for any visiting vehicles, and all of this just setting up ultimately for the deorbit burn and the landing of Dragon. Second departure burn has been executed.
Station Houston on 2 for Dragon.
Houston.
All right, departure burn 2 is complete, and you are go for SSRMS safing, and that's step 5 in 1.320.
And now the third departure burn for Dragon has begun, and that burn already completed. And the visiting vehicle officer here in Houston reporting everything's still looking good with Dragon's departure.
Round 2, departure burn 3 is complete, and Dragon is now outside the keep-out sphere.
Station copies, and we would like to give a big thank to all the operational team.
The capsule contained numerous technological and biological experiments, including a team of astronaut mice taking part in microgravity experiments. The studies looked at how microgravity affects blood vessels in the brain and eyes, as well as its impact on cartilage loss in hip and knee joints. The research will help scientists understand how arthritis develops and provide a better understanding of the visual impairments experienced by astronauts, which could in turn help to identify causes and treatments for eye disorders. Other research projects returned to Earth aboard the Dragon included experiments into growing lung tissue in microgravity and research into proteins implicated in Parkinson's disease. The Dragon CRS-12 capsule was launched last month from Pad 39A at the Kennedy Space Center at the Cape Canaveral Air Force Base in Florida aboard a Falcon 9 rocket. The Dragon is currently the only operational spacecraft, other than the manned Soyuz capsule and the X-37B US Air Force Space Shuttle, equipped with a heat shield and capable of atmospheric re-entry. Dragon has therefore become the only way of returning large amounts of equipment and completed experiments back to Earth since the earlier retirement of NASA's Space Shuttle fleet. I'm Stuart Gary. You're listening to SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. And a new study has concluded there are more than 2 billion species of life on planet Earth. To date, only about 1.5 million species have been formally described in the scientific literature, and most of those are insects. Proportionally, bacteria comprise less than 1% of all described species. Scientists generally agree that more species exist than are formally described, but they disagree about how many there really are. Some studies have estimated 2 million or fewer, whereas others have suggested as many as 12 million, and one recent study even suggested the planet could be home to 1 trillion species. The new findings, reported in the Quarterly Review of Biology, estimates there are roughly 2 billion living species on Earth. That's over 1,000 times more than the current number of described species. Researchers reached their conclusions by looking at findings estimating there are at least 6.8 million insect species alone. They incorporated new estimates of species boundaries revealed by DNA sequences, which suggests there might be 6 times as many insect species, increasing the total number of insect species to 40 million. They then reviewed all the groups of organisms associated with insects, things like parasites and symbionts. They found that each insect species most likely hosts a unique species of mite, roundworm nematode, a one-celled fungus called microsporidium, and another one-celled organism called an apicomplexy protist. You probably know it better as being the cause of malaria in humans. Most importantly, researchers estimate that each insect species was likely to host at least 10 bacterial species found nowhere else. Now, based on these estimates, they deduced there should be around 2 billion species on Earth. The authors also suggest that the diagram of which taxonomic groups contain the most species, the so-called pie chart of life, is very different from traditional estimates. Rather than being dominated by insects as traditionally shown, their estimates show a pie chart dominated by between 70 and 90% bacteria species, with insects and animals in general having a much smaller slice. A new NASA study has located the Antarctic glaciers that have accelerated the fastest between 2008 and 2014, finding the most likely cause for their speed-up was an influx of warm water where they're located. The new study, reported in the journal Earth and Planetary Science Letters, found that the water was only a degree or so warmer than usual water temperatures in the area. Still, that was enough to increase glacial flow by up to 25%, multiplying the rate of glacial ice loss by 3 to 5 times from 2 to 3 metres per year up to a new high of 10 metres per year. Researchers from NASA's Jet Propulsion Laboratory in Pasadena, California, found that the warmer water was being driven into the area by winds associated with 2 global climate patterns, La Niña and the lesser-known southern annular mode, which involves a change in the location of the belt of winds that encircle Antarctica. Interestingly, while these glaciers accelerated during a La Niña event, the nearby Pine Island Glacier, one of West Antarctica's fastest-moving glaciers, melts faster during El Niños, the opposite climatic pattern to La Niña. This alternating response to global atmospheric patterns underscores the need to improve science's understanding of the links between global climate and changes in polar oceans. A new study has concluded that women with coronary heart disease are less likely to achieve treatment targets than men. The new research analysed data from over 10,000 patients with heart disease from Europe, Asia and the Middle East, including 2,900 women. Scientists found that compared with men, women were less likely to achieve targets for total cholesterol, LDL cholesterol and blood glucose, or be physically active or non-obese. In contrast, however, women did have better control of their blood pressure, and they were far more likely to be non-smokers than men. Crown-owned segments of land originally used to help travelling livestock get to market have now become a haven for native plant species according to new Australian research. The study compared travelling stock reserve land with land used for primary production across the Riverina region of New South Wales. It found a big difference in the makeup of plants that are important for threatened animals. The authors say that's probably because travelling stock reserves have a history of lower grazing pressure. The study provides evidence showing the high conservation value of travelling stock reserves. New research has uncovered a rare state of matter in which electrons in a superconducting crystal organise collectively. The findings, reported in the journal Nature, are based on research trying to answer one of the most compelling questions in physics, namely, how do correlated electron systems work and are they related to one another? Electrons in most metals act individually, free to move through a metal and conduct electric currents and heat. However, in a special sample of layered cerium, rhodium and indium, scientists discovered that the electrons unite to flow in the same direction, a behaviour called breaking symmetry, when in the presence of high magnetic fields of 30 Tesla. Known as electronic pneumatic, this is a rare state of matter between liquid and crystal. Scientists believe that the electronic pneumaticity state may be closely related to superconductivity, another strongly correlated electron state in which electrons flow with no resistance. The cerium crystal becomes a superconductor under high pressure. However, when placed in a high magnetic field, it demonstrates this electronic pneumatic state. Because it exhibits both behaviours, cerium crystals appears uniquely positioned to reveal possible interactions between these two correlated electron phases. The researchers are now exploring how the pneumatic phase merges with the superconducting phase. And finally for now, it looks like the British sitcom Absolutely Fabulous was far closer to the truth than most want to admit, after a new study found that today's teenagers aren't nearly as wild as their parents were. The research, reported in the journal Child Development, looked at how often today's teenagers engaged in the sort of activities that adults do and that children typically don't. These include things like dating, working for pay, going out without their parents, driving, drinking alcohol, and having sex. The researchers analysed survey data on 8.3 million 13 to 19-year-olds between 1976 and 2016. Surprisingly, they found that today's adolescents are far less likely than their predecessors to take part in activities typically undertaken by adults. Interestingly, the trend appeared right across demographic groups, even when taking into account gender, race or ethnicity, socioeconomic status, and exactly where they came from, be it urban or rural. The researchers say that suggests a broad-based cultural shift. The findings mean the developmental trajectory of adolescence has slowed, with teens growing up more slowly than they used to. In terms of adult activities, it means 18-year-olds now look and act far more like 15-year-olds once did. The authors did note one very important proviso, and that is that the decline may well be linked to the amount of time teens spend online, something which has been increasing exponentially. You're listening to Space Time. I'm Stuart Gary. And that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, your favourite podcast download provider, or direct from spacetimewithstuartgary.com. The show's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., around the world on TuneIn Radio, and as part of Virgin Australia's in-flight entertainment. If you want more space time, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and other things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, and on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. Subscribe at iTunes, Stitcher, Pocket Casts or Audio Boom. This has been another quality podcast production from Bytes.com.
This episode of Space Time has been brought to you by Brilliant.org, maths and science done right. And remember to use our special link so they know you've come from us. That's Brilliant.org/Stuart Gary.